Hello, folks. I just want to give a quick rundown of Lab 3, make sure everybody's on track for that. It's the usual process for going through and obtaining the lab, right? Our SSH fork and clone and moving into our Lab 3 directory. So I will let you grab that as normal. Once you get in there, you're going to see a collection of a half dozen or so C++ files, a makefile as usual, a README. And so the C++ files are going to be structured around the idea that we're going to be maintaining a linked list. And this is going to be quite similar to the kinds of ideas we've been looking at in the lectures. So there's going to be a struct to represent individual nodes in the list. So this will be our nodes. We've got a header file for it that contains the definition of the struct, a .cpp file that's got some functions to manipulate the nodes. Then there's one for the list as a whole. So our kv list information is going to be in this kv.h and kv.cpp. And then the program that uses our lists is going to be in lab3.cpp and its accompanying lab3.h. So all of the hash includes and the pragmas and that sort of thing have been set up. So you can grab it, type make, and it should compile it all together. In this particular lab, most of what I want you to do is actually writing the functions that manipulate the linked list itself. So the program is completely provided. lab3.h and lab3.cpp are finished. Similarly, the information for dealing with an individual node, the kv node.h and kv node.cpp, they're completed. You don't need to do anything there. The header file for the kv.h is pretty much in place, I think. And so what you're going to be doing is finishing off each of these linked list routines, so functions to do things like inserts and removes and displays and whatnot. So you're going to be writing the functions that are in this kv.cpp. So that is the one file that you're going to be editing from a C++ perspective, plus of course the README to describe what's going on. But again, pretty much everything else is done for you. So as with the previous lab, if you just use make to build the executables, it builds two versions, the lab3x, the kind of normal one if you like, and then a lab3g that is suitable for use with the debugger if you want to use GDB to experiment with what's going on. You should follow your normal design and implementation cycle. And again, this time around, you're just going to be editing this one file, kv.cpp, and your README. And so when you're doing your adds and commits and pushes and things, remember to add those two files, do your commit, and do your push. So the meat, what is this thing actually doing? So, we're actually getting into the programming details for, how about lab 3? Bit of a typo there. Cut and paste error, actually, I'm sure. So what we're trying to do is, again, work with linked lists. So this program is keeping a linked list of information where each kind of data component, if you like, involves an integer key, an associated numeric value, and then a text description of that key value pair. So each of the nodes in our linked list is going to have a key, a value, and a description, plus pointers to the nodes before and after it in the list. So again, we're going to be using these linked lists to store data. Each has a unique integer key, an associated real number, and a plain text description. Now, what we're going to be doing within these lists eventually is maintaining them in sorted order. So each time you do an insert, you're going to be inserting it into the list in its right sorted position in the existing list. In the beginning, I'd say just insert at the front or insert at the back until you get kind of the basics of your program working, and then start worrying about how to update your insert so it actually gets things in the sorted position. But again, incremental design, right? Get simple pieces working first, and then gradually expand to more complex operations. So what the program actually does is let the user just keep making choices about what they want to do with the list. Do they want to insert a new item? Do they want to remove an item? Do they want to print the list? Do they want to search the list for a particular item? You give it the key and they'll find the item and tell you its value and its description. So a whole bunch of different operations that we're going through to try and provide. And again, as far as the structures go, we'll have these KB nodes that represent individual nodes and functions for them in the KB node, KB node.h and .cpp that are built for you, and then this KV list that are in the actually the KV file, not KV list file, and along with descriptions of what's going on there. So the functions that you're going to be implementing are these 8 functions in the kv.cpp. One to take kv list struct and initialize it as an empty list. One to delete everything in a list. One to print the entire contents of a list. One to look up the current size. One to take a key and look it up in the list and return a pointer to that node in the list. One to do a lookup, again given a key, but this time obtaining the value and description that go along with it. And for that one, I would suggest it simply call the earlier version of lookup and use that value once it gets it. An insert to either insert a new key value description node into the list, right? Create it and insert it. Or if that key is already in there, to update the value and description associated with it. Or one where we give it the key and it removes that node from the list if it is in the node, if it's in the list at all. So we'll take a quick look at the files and things in just a moment, but that is the general idea. Again, the only things that you're modifying are the kv.cpp and your readme. You're completing each of the functions that are in that kv.cpp, and again, there's a description of them in the header file and the kind of empty skeleton version of them in the kv.cpp. And if you want to have a boo, again, I've thrown in a copy of the code here, but we'll actually take a look in just 1 second to have a look at the source code in the repository when you first grab it. So we'll do that in just a second. In terms of sample runs, again, the body of the program is already implemented, the main routine and all of these prompts and all that sort of thing is already there. So when you run the program, essentially what it's going to do is provide the user with the opportunity to enter a command, a single letter command, and then process that command. So H is the help command, and it prints the menu of the different things that they can do. So they can enter an H to print the menu, an I to do an insert, a P to print the list, L for a lookup, R for a remove, Q for a quit. And again, you can run through a sample run here where it just says, okay, ask for a command. If it's an insert, it asks them, okay, give me the key, give me the value, give me a description, does the insert, lets you know what happened, whether it's succeeded or failed. So again, you can have a look at this, but let's try a bit of a play with our actual repository here. So once you've forked and cloned your repo, again, it's going to look something like this, where you've got the kv.cpp and .h, and so those are the ones for the list, the node.cpp and .h, so those are the ones for the individual nodes, and the lab3.cpp and .h, those are the ones for the program itself, the makefile, and your readme. So if we have a look at some of those, and if we look at the kv node.h, for instance, again, it's pretty much got the struct for the node, so it contains a long for the unique integer key, it's got a string for the description field, a double for that numeric value that's associated with it, and pointers to the next and previous nodes in line. And then in terms of supporting functions, there's a print data that just displays the contents of the node. You should be calling this whenever you want to print the contents of a node, right? Don't write up your own secondary print routine for printing the contents of a node. This has got the format that we want to see. So call print data whenever you want to display one of these things. And similarly, there's a create function that's already provided that allocates a new node. You give it the key, the description, and the value. It creates a new node and returns a pointer to the node it created. So you call create, it gives you back a pointer to the node it successfully went off and created. And again, if you have a look in the kvnode.cpp, you'll see the implementations of those two functions, right? The implementation of create, where it allocates a new node. As long as it worked, it fills in the fields and returns a pointer. If anything went wrong, it just uses the null and prints out an error message. And again, the format for the print data to get the output displayed correctly. And again, if you want to have a look at the main routine, right, lab3.h has a list of the commands that are available and a handful of functions that the main program uses, right? One to get a command, to get a number from the user, to get a key from the user, that kind of an idea. And the lab3.cpp is essentially just the main routine that repeatedly goes through this process of get a command from the user, process it, right? We'll create a list, initialize it, get a command from the user, and process it, repeating until the user eventually decides to quit. And so you can have a look through the code that's in there and how it calls some of the different list functions that you're going to be implementing. It'll be somewhere down here in process. So in process, it goes through and gets the key, the value, the description from the user. And once it's got that, it calls the insert routine that you're going to be running. Right? So there's a sample call to the insert function that you're going to be implementing. Or, here's a sample call to the lookup function that you're going to be implementing. Or a sample call to the remove function that you're going to be implementing. So if you want to see how this stuff is being used, that's where it is. But of course, the one that we're interested in is the collection of functions that you're actually going to be implementing. So in kv.h, we've got the definition of a struct for the list as a whole. So this follows the same sort of argument as we used in the lectures, where to keep information about the list, we'll have a pointer to the first node in it, the front node, and to the last node, the back node. So the front one will be the one with the lowest key, the back one will be the one with the highest key. And this time around, we're actually throwing in an extra field just to keep track of how many nodes that we've got in the list right now. So each time you insert a new node into the list, you'll bump this up by 1. Each time you remove a node from the list, you'll decrement this by 1, just so this is always an accurate count of how many things are in there. So then you'll see descriptions of the different functions that you're going to be implementing. So an initialize function that just sets front and back to null and that number of nodes to 0. A deallocate that goes through the list from front to back, deleting everything in there. An insert that says, okay, well, here's my list, passed by reference so that I can change front and back and the number of nodes if I need to. The key, the description, and the value that I want to insert. And so this would be going through and doing a, calling create and inserting that newly created node into this list somewhere. Right? So again, functions for insert, for remove, 2 versions of lookup, one that goes through the list looking for the first node it can find with that specific key and just returning a pointer to it, returning null if it doesn't find it. And then our secondary version, that's the one that the main program would actually be calling, is saying, okay, in my list, I want to look up this key, or the first node you find with this key, and update the description and value. So find the node with that key, copy its description into D, copy its value into V, so we can get the information about that particular node. All right, so what I would suggest for lookup and remove and insert is the first thing each of them does is just call this other lookup function, say, hey, is this node in the list? It gives you a pointer to the node that if it finds it, and returns null if it's not. That way, you don't have to have a chunk of search code written in search, or in insert, and a chunk of search code written in remove, and a chunk of search code written in this general lookup. Each of them is just going to call this lookup function, and that's going to be the only place where the real searching of the list takes place. So that is the intent there. What else? One function that's pretty straightforward that just returns the size of the list, the num nodes field or end nodes field, and one to go through and print the contents of the list. So those should actually look pretty similar to the kinds of things we've been doing in the lectures. And if you have a look in your kv.cpp, again, you'll see empty versions of each of those functions currently. So Right now, it'll compile and run, but none of your list functions actually do anything, so you can't actually put anything in the list or search for anything in the list. So if we try compiling it, we'll see a ton of warnings because none of these functions are using any of their parameters, but it will compile, I hope. Yeah, so lots of warnings for unused parameters, but it does compile, creates our lab3G, right, the debugging version, and our lab3X, the one we can run. And you can actually run it, it just can't do anything with the list right now. So it asks you for your command, you say help, what were my options? So I can try things like printing the list, but there's nothing in the list. I can try doing a lookup and it'll ask me for the key. And of course it can't find it because there's nothing in the list. But it does give the options, it does run at this point, and eventually we can quit to get out. So hopefully that is enough to get everybody started with this, and yeah, we'll see how things go.